Question 5, and we're in differentiation territory here. Part 1 for 6 marks is quite nice actually, because we're just finding stationary points. It's a process we've practiced over and over and over again, so crack on with it. We differentiate the original function, and then what a lot of people then do is they set it equal to 0 like that. Now just avoid doing it on the same line. It's a little bit like saying something like, I went to the shop was closed, instead of I went to the shop, it was closed. So separate line, separate sentence in maths, we're going to set that derivative equal to 0. Now you don't need to go through all the rigmarole of solving this. You have a ClassWiz calculator which can do this bit for you. So use it, speed things up. It doesn't say it needs to show all of your working here, it just says find. So we can solve that to get the x values and then substitute those back into the original function to get the 2 y values, and we're done. Now this question is actually lifted from the old syllabus, where they would expect you to solve that quadratic, and they give you marks for solving the quadratic. So that question in the new syllabus would not be worth 6 marks, it'd probably be worth 4. Now the question does ask for coordinates, so give the examiner what they are asking for. Don't make them hunt around for your correct maths. Give them exactly what they want. Okay, part 2. Determine. Now the question says determine. The question 1 said find. It just wants the answers. Question 2 says determine. That's another way of saying show all of your working. So it doesn't just want the answers, you need to figure it out, you need to show the process. The easiest way, the most efficient way to determine the nature of a stationary point is to use the second derivative. So differentiate our first derivative again, and then we substitute numbers into the second derivative. So when x is minus 3, calculate it, you do minus 6, subtract 6 lots of minus 3, and you get 12, which is positive, and therefore it's a minimum. And then don't just write that the other one's a maximum, we have to also show that. So when x equals 1, second derivative, calculate to be minus 12, which is negative, and therefore it's a maximum. Now, again, what's a minimum, what's a maximum? Tell the examiner exactly what they want to see, or what they want to hear. So there's a minimum at that point, and a maximum at that point. Great. Part 3, it's asking about an increasing function, the definition of an increasing function, or the part of a function where it is increasing. It's just where it's got positive gradient, that's all it's saying. So it's asking which part of the curve has positive gradient. Well, hopefully you've spotted that this is a negative cubic. Negative cubics have this sort of shape. So our turning points we can mark on here. Those are the same ones we've found. There's our minimum, which we've determined to be a minimum, and a maximum. And the function's increasing, it's got positive gradient just between those 2 points, indicated there in red. All the other parts of the curve are negative gradient. So that's just your answer, just x values between minus 3 and 1.